Hello, it's Dr. Daystorms once again, and today this video is going to focus on formula and molecular weights, and then also how to find a percent composition of an element within the compound. Okay, so if we review a little, remember we've been talking about two different types of intermolecular interatomic bonding. We have the ionic bonds, which are represented by an empirical formula. For example, 1 sodium for every 1 chloride anion. And then we have those that have the molecular formulas, like carbon dioxide. Okay? And so we can actually use the periodic table and the elemental atomic mass for each of the atoms in it in order to determine what's called the formula weight for an ionic compound, or the molecular weight if it's a molecule like carbon dioxide. So let's go ahead and get started. So the formula weight, it's very simple. All you do is it's the sum of the atomic weights for the atom in the chemical formula. So for example, let's work on one of these. So let's go ahead and let's determine the formula weight for magnesium sulfate. In order to do this, we're going to need to know a few things. For example, if we want to do magnesium sulfate, we need to know the actual ionic number of ions. I should say the actual chemical formula for it. And so we have magnesium, which is a 2+ ion, and sulfate, which is a 2-, so it's going to be in a 1-to-1 ratio. So what do we need to figure out? We need to find out the molecular weight for the atomic mass for each magnesium, for the sulfur, and for oxygen. So we're going to have to look at our periodic table. So let's bring up a periodic table real quick. So if we look here at the periodic table, we need to find magnesium, sulfur, and oxygen. So here's magnesium, here's sulfur, and there's oxygen. Okay, so let's write down the atomic weight for each of these. I'm only going to go to the hundredths spot for each one. So magnesium is 24.31 grams, or AMU. Oxygen would be 16.00, and sulfur is 32.06. So once again, we have a magnesium, and each magnesium is 24.31 AMU. We have a sulfur, and each sulfur is 32.06 AMU. And then we have oxygen, and each oxygen is 16.00. However, we have 4 of them, and so we're going to have to multiply this by 4. Because remember, the chemical formula for it is MgSO4. So that would be equal to 64.00 AMU. So now let's just add these together. So let me get out my trusty calculator. $24.31 plus 32.06 plus 64, and I get the number 120.37 AMU. And so that would be my final answer. So if we did another example, like calcium chloride, we already have that one calcium is 40.1 AMU, chloride, each one is 35.5 if you only go to the 10th position. So you have to multiply that by 2. When you add those together, it's 111.1 AMUs. Generally, when we talk about formula weight, we're reporting them for ionic compounds, whereas we use the term molecular weight whenever we want to talk about the atomic weight for a molecular compound. So if we look at the example here, a molecular weight is just the sum of the atomic weights in a molecule, and it's done exactly like you do for the formula weight. So if we want to look at ethane, we would have each carbon at 12.0 AMU and each hydrogen at 1.0. So we would have 24 plus 6, which is 30 AMUs. Let's do one more example. Let's look at table sugar, which is C12H22O11. So we would have to do 12. Sorry about that. Kind of give away the answer quickly. We'd have to do for each carbon. So we'd have 12 times 12.01. I would get that from the periodic table. Plus, for each hydrogen is 1.01. And we have 22 of those. And then we have 11 oxygens. And each oxygen is equal to 16.00. So, if we add these all up, 12 times 12.01 plus 22 times 1.01 plus 11 times 16.00, we will get a final answer of 320.34 AMUs. It's not very difficult at all. Next, we're going to try and do something called percent composition. And this is where you find the percentage of the mass of a compound that comes from each of the elements in the compound. The equation is percentage of that element is the number of atoms times the atomic weight divided by the formula or molecular weight. And since it's a percent, we want to multiply it by 100. So let's go ahead and just do an example. Okay. So if we want to look at the percent of carbon in ethane, we're going to need to know the following. First off, we need to take the total number of carbons, which is 2, times its atomic mass, which is 12.01, divide it by the total. Okay, which is the total times 2 plus 1.01 times 6 is 30.08. Then we take this entire number, and to turn it into a percent, you just have to multiply it by 100. So we're going to have 2 times 12.01, divide that by 30.08 times 100, and it comes out to be 79.85%, or roughly 80%, depending upon your rounding. Okay. So let's do another example. Let's do a completely different example now. So let's do another example. Let's find out or figure out the percent oxygen in acetate, in acetic acid, which is vinegar, essentially. And so acetic acid is C2H4O2. We're going to need to let's find out the percent oxygen in that. So we're going to need to know carbon, which is 12.01, helium, which is 1.01, and oxygen, which is 16.00. Okay. Alright, so we want to find the percent oxygen. But to do that, we need to know the total molecular weight of acetic acid. So we're going to have 2 times 12.01 plus 4 times 1.01 plus 2 times 16.00. So let's enter those numbers into our trusty calculator. 2 times 12.01 plus 4 times 1.01 plus 2 times 16. We get 60.06. So to find the percent oxygen, what we need to do is you take 2 times 16.00, divide that by 60.06 times 100. That's going to equal divide by 60 times 100, and you only multiply by 100 to make it a percent. And you get 53.28% oxygen. Hopefully this has helped you learn how to do the formula weight, molecular weight, and the percent composition. I'll see you in class.